Hey everybody, I'm here with Jason Rhinelander today. He's an Oxen dev and the mastermind behind Blink, which is a feature allowing for instant transactions using Oxen. And that's going to be the subject of our discussion today, so welcome Jason.
Hi.
So first things first, Jason, for the people who don't know, can you just explain a little bit about what Blink actually is?
Sure. So Blink is our instant payment mechanism, and it's the current implementation of Blink basically says that I can send you a transaction, and you can get it within a couple of seconds, and you have a guarantee that that's coming into your wallet. That guarantee is kind of provided by the network. So the network says, yes, this transaction is good, and yes, we're going to prevent other transactions that could conflict with this one from being allowed into the blockchain. So essentially it says, okay, we're signing off on this, it's coming in, and that's it. And you get a strong guarantee that that is coming into your wallet, even before it actually gets there. It doesn't give you the funds instantly, but it does give you that strong guarantee that you're going to get those funds. So if I was coming to you and you were selling me something, you could say, hey, it's a Blink transaction, it's signed by the network, we exchange the thing, and everyone's happy.
So when did you first get the idea for Blink or start working on it?
So there's a complicated history behind that. So it goes back. Some people in our community will know some of the details of this story, but it goes back to a cryptocurrency called Graft. And Graft launched, I think, about 3 or 4 months, maybe a little more, before Oxen, or Loki, as we called it back then. And it was this coin that was promising to do all sorts of things. It was promising to have real-time payments and to have instant transactions in different currencies that could get traded on the network. And it's going to have all this wonderful stuff. And it was going to replace Visa. And it was going to give you cake. And, it was like, it had everything. So I was pretty excited by that idea when I heard about it back in, I guess this would have been very early 2018. And I was just starting to get interested and involved in cryptocurrencies. So I thought the idea was a pretty cool thing. So I got involved in that community. And after a little while, I started running a pool. We started a community group to sort of push forward the ideas of what Graft wanted to be. Now, one of Graft's things was this idea of this, what Graft called a real-time authorization. And that was the idea that you could send this payment, and even before it gets confirmed on the blockchain, you have that guarantee. And that's about what I described earlier of what Blink is. However, the way that Graft proposed doing it didn't work very well. There were some substantial problems. And I tried to work in that community and say, well, look, we got to solve these problems and these problems. I didn't get very far. It was a developer group that wasn't particularly interested in outside people telling them what they should be doing. Fast forward a couple of months, and the shine is starting to come off Graft. But meanwhile, here's this new coin called Loki that was launching and had gone through, its initial launch period, and it was just about to launch service nodes. And I looked at that and I said, well, that's a pretty interesting chain. They want to do some of the same things, but they also have these really cool applications to privacy. So I started to get involved in the Loki community around that point. And started, I think, along with a lot of people, to get disillusioned with what was happening in Graft. But I wasn't involved at first as a developer. I actually got, if people remember the history, I got into a long public conversation with Simon about challenging the ideas behind the Loki Foundation. And it was very public, and I was really impressed with the fact that people who were seriously embedded in this were willing to have a critical discussion of the project in public discussions. So not long after that, Simon, I was doing other things around the time. I started up like the Loki SN bot that lots of people know for monitoring service nodes. And Simon extended an invitation to me to join the Loki Foundation as a member, and a few months later as a director of the foundation. So that was kind of how I got involved to start within the project. A few months after that, I was looking for a job, and the project said, "Hey, you'd be a great fit here," offered me a job, and sort of that's where I've been now for a little more than 2 years. So when I came in, the first thing that I worked on was Blink, which is this real-time authorization. So I had thought about this product, this idea a lot, thinking about it critically from what Graft had done and the mistakes that they had made and how it would need to be done better. So my first task was really to say, well, let's design this in a way that doesn't have all these problems that Graft was having, and that works for Loki. Now Oxen, of course.
But obviously there was the whole Graft project, which was building up to this real-time authorization. But once you actually arrived at what was then Loki, now Oxen, how long did it take you working on Blink and building it to actually get to a point where you had Blink, it was going on mainnet, and it was working?
The design sort of went in stages. So the first thing that I did, rather than, before I sat down and wrote any of the code for it, I created a white paper for it. You can still find that in the Oxen, I think it's in the Oxen improvements proposals. It's one of the RFCs listed there. And, if you were to print it out, it'd be, 25 or 30 pages long. And it covers kind of all the details of how it works. So how it interacts with the service node network, how we handle various edge cases, how we handle, when service nodes get this thing, how they pass it around so that everybody has a chance to sign off on it. So all of that is in there, along with various mechanisms of we need to do this particular thing to address that potential attack of the system. So that was the first step, and that took me at least a month, really, to sort of just nail down all the design pieces. And then I started putting it in, and I honestly can't tell you exactly how long it took, but it was the first major thing that I did in the project when I started as a full-time dev. And I'm pretty pleased with that we got it out and we got it working, and it's been solid.
Yeah, it's truly excellent. One of my favorite parts about Oxen, to be honest with you. Can you go through a little bit? Obviously, you've just said there, there was a 25 to 30 page white paper describing the design for Blink. But just briefly, can you go over technically how that real-time authorization that is Blink is achieved?
So what happens is when you want to send a Blink transaction, you'll connect to your node. And this could be a public node, or it could be a node you're running on your own machine. And you'll say, here's my transaction, and I want this to be a Blink transaction. So if it's a Blink transaction, there's some extra fees, and a portion of those fees get burned. And so your wallet takes care of saying, okay, well, I've constructed this properly. It's a Blink transaction. I burned the right amount. Send this off to the network. So at any given moment on the network, you can look at the current block height, and that tells you, here are the service nodes that are the quorum for Blink. So you say, okay, well, I'm going to send this transaction to those service nodes. And there are, I'm pretty sure it's 10 of them at a time. But it's actually gets more complicated than that, because it's not just that there's 10 here. There are another pair of 10 over here. And you have to send that transaction to both of them and get at least 7 of the 10 to sign off over here, and at least 7 of the 10 to sign off over here. And the reason for this is it actually makes things considerably more complicated. It's or considerably more statistically complicated to actually abuse this thing. So you send it to quorum 1 and you send it to quorum 2, and you have to get the supermajority in both of those quorums before we can move on. And if they decide to move on, what happens is they put their own signature on here and say, I'm service node, quorum whatever the block height is. I'm service node 3. Here's my signature on this transaction that says, I say this transaction is good. So you get all these signatures. You get these 14 signatures. You need 7 at least from each of them. And they get added into this transaction. And as soon as that happens on those service nodes itself, it says, hey, this transaction's got enough signatures now. Let me start distributing it to the network. So it goes from my wallet to my node. My node sends it into these quorums. It picks 2 or 3 random members from each of these quorums. And then those quorums distribute it within themselves. So everybody in there gets it. And so my wallet, my node, these quorums, and then throughout the quorums, and then once they say we've got enough signatures, they distribute it out to the network. So it's you get this pretty rapid distribution because it gets essentially distributed by 20 different nodes on the network. And because of those signatures, people will say, well, those signatures are the thing that we trust. So when you receive this, your node says, hey, we received this Blink transaction. Let me check the signatures and make sure someone didn't just put some fake signatures in here. And if it is, then it comes back to your wallet, who I'm sending it to. And your wallet says, yeah, this looks good. It's got all the signatures. I'm going to count that as part of my balance right away without having to wait for it to be mined. So there's a lot of complication in there. And the reason for that, like for the 2 quorums, for example, the reason for that is it's really hard to abuse 2 quorums. So let's say you had like a quarter of all the service nodes on the network, and you said, I want to put signatures on this fake transaction that I know cannot actually get out there, but I'm going to sign it and I'm going to pretend that it gets out there. It's difficult, but not impossible for you to gain control of one of those quorums. But it's virtually impossible for you to gain control of both of them at once. You'd have to basically have, you could work it out, and it depends on what your threshold for being impossible is. But if the way it's designed, the details were in the white paper, and I ran some of these calculations. But the way it's designed is, if you owned 25% of all the service nodes on the network, you would have one possible chance in something like 100 years of just randomly getting your service nodes in both of those quorums selected in such a way that you could actually sign on a fake transaction. So you'd have to be waiting for it, and it may never come. And if you are nefarious in the first place, and you're saying you want to actually damage the network while you're staked into 25% of the network, then the incentives don't even align.
Yeah. So in terms of the future of Blink, now that it's built and it works, how would you like to see that technology used in the future?
I'd love to see Blink get used for handling payments in Oxen. And it's something that we still have to, as the Oxen team, we still have to actually push that out there a bit more, because the vast majority of what we're seeing now are people using service nodes. So we still have some work to do on building demand to get people actually using them. But the day that I can go to buy something with Oxen where I'm not specifically going somewhere to buy it and I just see it, that would be the moment for me that says, hey, this is really working. This is my work is done.
And there's one more major milestone, I suppose, in the future of Blink, and that's reblink. Can you just briefly explain what reblinking is?
So reblink, I alluded to this a little bit earlier, but right now what happens when you get a Blink transaction, it says, okay, that's a value in my wallet, but you still have to wait the required 10 blocks for it to get confirmed by the network before you can actually spend that. And we do have the ability to shorten that. So we could shorten that to 1 or 2 blocks safely because of the Blink signatures that are on it. But one of the problems, that's not good enough. And what we want to be able to do is I send this thing to you, you get it, and immediately you turn around and you send some funds from that transaction to someone else. before anything has been put into a block at all. So reblink is this idea that you can get it and you can instantly turn around and send it. And you don't have to worry about when it goes into a block, because all of these signatures are essentially a guarantee that it will get into a block. And it might not for 5 minutes or 10 minutes from now, but it doesn't matter. You can turn around and you can create another thing. The network will see that the new transaction that you created, that it depends on this one that hasn't been mined, but it'll say that's okay, because that's the way that reblink works. So it's always been part of the design for reblink to come around. It's been kind of put off on the back burner for quite a while now. And that's because we have all sorts of other cool stuff that we're doing in the project. I mean, I've spent time on LokiNet. I've spent time in storage server. In some of my work now is in the session open group server. Like, there's a lot of stuff that we're working on. But the biggest obstacle and the biggest reason that we haven't undertaken it is it requires some fairly deep changes in how we fundamentally build transactions. So one of the of course, what we use on the network are ring signatures. And this is essentially the anonymity property that we have, is to say, I'm going to put out this transaction and it's going to tell you that it's going to spend money from one of these 10 transactions. And you don't know which one it is, but there's a cryptographic proof that says, yes, I am actually spending one of these, without anybody being able to see which one, except for me. The problem is, if we were to immediately say, okay, well, you can just create this new transaction and it can spend from a transaction that is still in the memory pool, hasn't been put in a block yet, then anybody who sees that transaction would say, hey, that transaction is referencing this other transaction that it couldn't possibly have referenced under all the normal blockchain rules, because it's not in a block yet. So we have to say, well, first of all, we have to build this mechanism to say, you're allowed to reference this thing that isn't in a block. And that's obstacle number one. Part of the obstacle of that is the way that transactions reference themselves by what is called this global output index. So basically, every output of every transaction gets a number when it gets mined into a block. And other transactions reference what they're spending by referencing this number. But if I want to reference something in the memory pool, it's not in a block, it doesn't have a number, and so there's no way currently for me to reference it. So we have to actually change the structure to say, well, I can reference it either by that output index, or I can say, here's the transaction. I'm referencing that transaction output 2. And we could do that, but then the problem is, if the only thing that ever references one of these Blink transactions is other Blink transactions, you would look at a transaction and you could see, okay, that transaction is spending from these 9 transactions plus this one really recent Blink transaction. And you would look at it and say, hey, guess what? I can tell which transaction you're spending from here. So the ring signature would essentially become pretty useless in a lot of cases, because if you ever use that reblink capability, you're unmasking yourself. We might as well not have those decoys, because it's immediately obvious which transaction you're spending. So we have to do some other work, and this is the other complication of reblink. We have to do some other work on how we reference transactions, and we have to make all transactions potentially reference some current Blink transactions, even if it's not a Blink, even if it's not a reblink, because there has to be some plausible deniability here that if we include one of these memory pool transactions, it could validly be a decoy that isn't the real one. Otherwise, you look at it and you say, well, there's this transaction that can only be included if you're spending it. And, well, you don't have anonymity anymore because it's obvious what you're spending. So we need an ability to say, I'm going to build this transaction. It's going to have these decoys. And some of those decoys sometimes are going to be recent Blink transactions. That's the only way that we can say, well, we can put recent Blink transactions without you knowing that that's actually the one I'm spending. So that's the biggest obstacle that we've had, is kind of, we'd have to redesign quite a bit of the core transaction how transactions reference other transactions. And that is a fairly big task. So it is definitely something that is still on the roadmap and definitely something that I still want to do. It's at the moment, it doesn't have a huge, I guess what you'd say, it doesn't have a huge killer application.
Yeah.
So it's until we build something where there really is that big killer application, it is less priority than getting LokiNet working well and getting session up and running and all these other things. So it's there. I haven't forgotten about it. People bring it up all the time. I mean, originally the plan was probably for this to be done about a year and a half ago, but other priorities come up.
Mm-hmm. Plenty of work to be done, obviously, but still a very exciting future for Blink.
There's always endless amounts of work to be done.
Obviously, as everybody is constantly reminding you, I'm sure.
There's one little tidbit that I'm going to drop in here that is sort of related to Blink, but it's I want to drop it because it's kind of cool. And so one of the things that I want to do on the blockchain before session monetization comes around is the ability to have a subscription payment. So this would be something where you can say, my wallet's going to submit this to the network. It's going to say, I want to pay this or burn, I guess would be for session payments. I want to burn this amount on this date unless I submit another transaction to the network that cancels it. So the idea here is you would be able to say, here's my wallet. I want to set up subscriptions, and they could be, burning things for session, or they could be, making a payment to you. Just every month I pay you $5 for your awesome work. And I could set it up in my wallet, and the wallet would make sure that these are all reserved off into the future. And it would have a list for me to say, here are my pending payments, and give me the ability to cancel them. And if I don't cancel them, you get the funds when the prescribed time arrives. So, and of course, it would all be blinked.
I think that could even be a good further discussion for next time. Actually, that sounds really interesting. But I think that pretty much wraps everything up for today. So thanks, Jason, for sitting down and chatting with me about Blink, and we'll see everybody next time.